Hey everybody, it's Mr. Patron, and in this video, we're going to wrap up Unit 6, Lesson 2 with a quick video about half reactions. So we're doing this to give you a little break from watching everything on the Zoom and to give you some flexibility with this particular bit of the lesson. So I'm just going to share my screen to jump back to the slides. And we're going to look at, like I said, something called half reaction. So we've been talking about redox reactions, these oxidation and reduction processes. And these particular chemical processes that are found in redox reactions can be written as things called half reactions. Make that E a little bit more clear. And these are known as half reactions because each consists of solely the oxidation or reduction process. So each is representing one half of the redox reaction. So a oxidation reduction or a redox reaction consists of two half reactions combined together, two halves make a whole. So this is what we're going to be looking at now. So these are two separate half reactions. And just a reminder, oxidation is the loss of electrons. So loss of electrons is oxidation. And then reduction is gaining. So be mindful of that there. Okay. So now we're going to look at some examples. All right, so we're going back to the reaction that we saw earlier in class, in which we determined which element was being oxidized and which was being reduced. So hopefully we recall that iron in this particular reaction is being oxidized. And then oxygen is the one being reduced. This is the reaction that causes rust to form. So rust is the oxidation of iron. And just a reminder of how we determined this, we looked at the oxidation states of each. So iron on the reactant side has a 0 oxidation state. And then oxygen also has a 0 oxidation state. And that's because these are both pure elements, Fe and O2. The O2 is still pure, even though it's made up of two atoms. They're just of the same element. And then it was determined through looking at the oxidation state rules that oxygen now has a -2 charge when it's on the product side. And then iron, in this case, has a +3 charge. So the charge on iron increased, leading it to be oxidized. So I'm going to note here, charge increased. And then for oxygen, it went from 0 to -2, so the charge went down. Hence being reduced. So we know how the charge is changing. We know which is oxidizing, which is being reduced. And we need to look at how electrons are transferred in these cases. So we're going to write these half reactions solely based on what happens to the electrons in these processes. So let's start with oxidation. So oxidation. Oxidation, you may recall, iron is the element being oxidized here. So what we're going to do to write these reactions is start off by writing out the element iron on both sides of the reaction. So once again, Fe turned into Fe+3, and I'll even put a 0 here, just to state that its oxidation number is 0. Now, in an oxidation process, we are losing electrons. In a chemical sense, what that means is that if we are losing something, it is going to be a product. So along with the iron ion, Fe+3 being a product here, electrons are also going to be written as a product because we are getting rid of them. They are now away from us. And given that the charge changed from 0 to +3, it increased by 3, we can say that overall, this process, we ended up losing 3 electrons. So our oxidation half reaction appears as such. Fe, with a 0 oxidation state, yields or produces Fe with a +3 oxidation state, plus 3 electrons. A couple things to note here. One, the oxidation process, as I mentioned, means that electrons are being released or lost in this case. So electrons will be on the product side of all oxidation processes. I'm just going to note that here. Electrons are products. And then one other thing to note is that we are following a concept known as the conservation of charge in these processes. So the charge on the reactant side, in this case 0, must balance the charge on the product side. In this case, +3 and -3 is also equal to 0. So, and we'll make sure that we follow that with the other as well. So once again, this is our oxidation half reaction. Now, let's go through our reduction half reaction. So once again, the oxygen is the one that is being reduced. And we're going to focus on just one of the atoms. So with these, we don't need to balance it. Both of the O's in O2 technically have a 0 oxidation state. So we're just going to put O with a 0 there. And then along with its product version. So on the product side, O has a -2 charge. And then just another thing to note, we have 2 irons here. We only have 1 here. We don't have to balance these at this particular moment. There are times in which balancing these half reactions does come in handy, but for what we're doing right now, we do not. So once again, with the oxidation reduction process, oxygen reduction process. Oxygen starts at a 0 charge and ends with a -2 charge. In reduction, because electrons are being gained, instead of being products, electrons are considered reactants. That's because the oxygen atom is taking these electrons on. So our final reaction is going to be O as an oxygen with a 0 charge, plus 2 electrons yields oxygen with a -2, so the oxygen ion. And just a reminder, in reduction, electrons are the reactants, so they're on the left side. And then also we are keeping the conservation of charge here, where our charge on the reactant side is -2 from the 2 electrons. And then on the right side is -2 from the oxygen ion. So we're going to go through one more of these reactions, one more of these sets of reactions. So let's clear this. And here. So this is the other reaction that we went over in class. So once again, copper chloride plus zinc yields copper plus zinc chloride. And first thing we need to do is just remind ourselves of which elements are being oxidized and which are being reduced. Again, we do that through looking at the oxidation states. So we can start where on our product side, we have zinc is by itself, so that is a 0 charge. Chlorine is a halide, and a rule with halides is that they are negative. And typically chlorine is -1. And then here, copper, because it is bonded to 2 chloride ions, is a plus 2. Now our product side. So here, copper is a 0 charge, and that's because copper is now by itself. Chlorine is still a -1. So the chloride ion has kept its charge, and it has not either oxidized nor reduced. So we can kind of eliminate it from our thinking here. And then zinc, following the same idea with copper in the reactant, has a +2 charge. It is bonded to 2 chloride ions, therefore it needs that +2 to balance that out. So once again, we look at which element is being oxidized and which is being reduced. The element that is being oxidized is the one that is increasing in charge, and that is going to be zinc. It goes from 0 to +2. So our oxidation half reaction starts with Zn, 0, yields Zn +2, and then we add on our electrons. So because we are increasing by a charge of 2, we need 2 electrons on this product side. Remember, oxidation is the loss of electrons. So that is, the electrons are a product in this case. And then for our reduction half reaction, we are dealing with the element that is losing charge, or charge is decreasing because we are gaining electrons. So in this case, copper is going from a +2 to a 0 charge. So Cu +2, and then Cu with a 0 charge here. It's that U. Once again, we want to keep our charges balanced. So whatever is on the left side must equate to what's on the right side in terms of charge. +2 and 0, to balance it out, we need to take on those 2 more electrons. And once again, this occurs on the reactant side because reduction is the gain of electrons. And those would be your half reactions for this process. Chlorine, or the chloride ion, once again does not change. It does not undergo oxidation nor reduction. So there is no half reaction here. This is actually known as a spectator ion. We're not going to worry about these at this very moment. But just keep in mind that for any redox reaction, there will be 1 oxidation process and 1 reduction process. Some elements will do neither. Okay, so your follow-up assignment is going to be some extra practice with these half reactions. There are 10 reactions you're going to look at. You're going to determine which elements are being oxidized and which are being reduced using the chart the chart method we used in class. And then you'll be writing half reactions that fit those particular elements. Feel free to reach out to your teacher if you have any specific questions, and have a great rest of your day. Bye.